6.2 is optional. And we're going to have vectors, which have bold notation in the textbook. And they have the little pointy guys, which means components. So that first one is your change in x. The second one is your change in y. And then if we have v, v1, v2, we're going to have a dot product. It's called a dot product. It looks like multiply. So you're going to see kind of a fatter dot. They will always write a dot. It won't be implied like multiplication is. So if you see a dot in between two vectors, it means a dot product, and this is what you're supposed to do. You're supposed to multiply the change in x's together. So in this case, it'll look like u1 times v1. I'm not putting a dot there. That means it's an implied multiplication. You're going to multiply. They're going to be actually numbers. You'll multiply them. And then you'll add that together with the changes in y. So the change in y times the change in y. So that actually turns into a number. So an example of that would be if I have 4, 5, dot product, 2, 3, those are components. That's your change in x and your change in y, but you do not write those component symbols when you're doing the problem. So we don't put those little pointy guys in the answer. So I'm going to say 4 times 2 plus 5 times 3, 8 plus 15, 23. So you start with vectors. These things, if you drew them, they look like little arrows, right? But when you do a dot product with vectors, you just have a number. That dot product is helpful for us to be able to find the angle between two vectors. And again, this is going to be worth extra points on the test. So if I need to find the angle, I am going to have the word cosine in there. Feels a little bit like trig. The numerator is going to be the dot product of the two vectors. So again, when I see a dot in between vectors, that means dot product. It doesn't mean multiply. And then I'm going to do the magnitude. That's what that double line deal is. That looks like absolutes, but when there's two of them, it means magnitude. Find the magnitude for u and multiply it to the magnitude for v. So an example is, I want to find the angle between u, which is 4, 3, and v, which is 3, 5. So I'll do the cosine of theta is the angle. So if I were to draw this, if I start here, I'll go to the right 4 and up 3. That's u. V is to the right 3 and up 5. So they're looking for that angle in between those two vectors. So in the numerator, I'm going to do the dot product. The dot product is take the two changes in x and multiply them together. So 4 times 3 plus 3 times 5. Terrible numbers. I'm going to highlight this 3 right there. And then in the numerator, we're doing magnitude. Magnitude is the square root. If you already know the components, I don't have to subtract. I can just say I want to take 4 squared plus 3 squared. And same thing, I already have the components, so I don't need to subtract. I just do 3 squared plus 5 squared. And I'm going to highlight that 3 so you know where those numbers came from. So I have cosine theta is 27 over 25 34 So the cosine of theta is going to be 27 over 5 root 34. It's an ugly number, but you're just going to do this in your calculator, so that's not important to know. Sometimes this is not a perfect square. You could just multiply this all together inside of the root. And that would be all inside the root. You don't need to worry about trying to take any of it out because you're going to do it in your calculator. So then if I want theta by itself, then I'm going to do inverse cosine on both sides. And that comes out to approximately 22.2 degrees.